Okay, we are going to continue from here. I think because everybody stay at home, they are using internet. The stream is not very good. We are talking about z-score, right? If the z-score is positive, means your score is above average. If z-score is negative, means your score is below the average. The standard deviation serves as a ruler. The standard, like a 1 mile, it's kind of like a unit, 1 unit. Okay, like where do you live? You live like to the east side of the school, 1 mile away, right? Yeah, it's kind of like a unit. That is the z-score. So we covered all the 3 measurements of the relative standing: quartile, percentile, and z-score. Another very important thing is a 5-number summary. 5-number summary. Which 5 numbers? If you have a data set, the 5-number summary of the data set would give you a good way to measure the relative standing of your score. The 5 numbers are minimum, Q1, Q2, Q3, and maximum. Good news is you are able to find the 5-number summary, all the 5 numbers from the calculator. Okay, and we have a type of diagram to describe the 5-number summary. It's called a box plot or box and whisker diagram. What happened is you have this line segment, okay, and you label minimum here, you label maximum here, and Q1 here, Q2 here, Q3 here, right? And then you draw a box using the Q1 as the left endpoint, Q3 as the right endpoint. You draw a box here of course your Q2. The median Q2 is gonna inside the box. So this is a box, this is a whisker, okay? And it tells you, kind of like give you some references. You can you would know, then you are able to know where is your value stand in the sample. Is it here or here or here or here, right? You actually know there are 25% here, 25% between Q2, Q3, 25% between Q1 to Q2, and 25% between minimum and Q1. Right? That is the 5-number summary and the box plot. All right, let's go over our package. Number 1, which measure of the center of a distribution is most affected by an outlier? Yeah, which measure of the center is most affected by an outlier? Mean, right? Remember? Mean is very sensitive to outlier. So number 1, answer is A. Number 2, which measure of center is at the peak of a right-skewed distribution? Right-skewed, we talk about that. It looks like this. It has a very long right tail. If we draw a histogram like that, we would have something like this. And where is the center? Which measure of the center is at the peak? At the peak of the right-skewed distribution. The answer is mode. Okay, the answer is mode. Why? Because that means most of the people, let's say this is C. Okay, yeah, most of the people, they got a C in the class. If we consider the letter grades of the students in the class, most of the people, they got a C. So the mode is a C. Am I clear about that? At the peak of the distribution, always corresponds to the mode of the distribution. Number 3, which of the following is not used to describe the shape of distribution? Number of peaks, it describes the shape. If you have one peak, that is the data set has one mode. If you have 2 peaks, the data set is bimodal. Variance describes how do your values in the sample deviate away from the center. Of course, it determines or describes the shape of distribution. Symmetric skewness, of course, is related to the shape, right? But the mean, median, and the mode, they describe the center of the distribution, not the shape. So we choose D. Number 4, which measure of center would you expect to be the largest? In a left-skewed distribution, left-skewed would have a longer left tail. Which measure of center would you expect be the biggest? That would be mode, okay? That would be mode. We choose C, because the peak is on the right for the left-skewed distribution. So that's gonna be the mode. All right? Median is supposed to be here. Mean is very sensitive to the outliers, right? And then median is supposed to be here. Yeah, anyway, the biggest one is the mode. Number 5, which of the following distributions is most likely to be uniform? A, the distribution of the heights of a sample of 100 college students. That might be a bell-shaped distribution. B, the distribution of the last digits of ID number in a sample of 100 college students. Yeah, that one is uniform. When we talk about histogram, I showed you 4 histograms. One is a bell shape, one is a uniform, one is skewed to the left, one is skewed to the right, right? Yeah, I actually used this example when we talked about that before. C, distribution of the scores on a mathematics exam taken by 100 college students is supposed to be bell-shaped. D, the distribution of the GPAs of a sample of 100 college students. That's supposed to be bell-shaped distribution as well. Number 6, find the mean of the following set of data. How do you find the mean? You add them up and you divide it by how many values in it? 1, 2, 3, 4, 5, 6, 7, 8. Divide by 8. Do you think you can do that on your own? You add them up and you divide by 8. Or you can use the calculator. I showed you how do you find the mean by using the calculator earlier, right? Number 7, find the median of the following data set. If we need to manually find a median, we need to sort the data set first. We put them in order, smallest and then biggest, right? Yeah. And we have, how many values do we have? We have 8 values. So if we cross out minimum, maximum, and we would have 2 values in the middle, right? And we're going to take the average of the 2 values. And then that would give us the median, MED, median. Okay? Number 8, find the mode of the following data set. Because we see 3.1 appears twice, all other values only appear once. So the mode is 3.1. Number 9, for the distribution skewed to the right, which has a longer right tail, the smallest center is mode. The peak is on the left, right? The peak, that is the mode. And the mean is the largest because it is sensitive to outliers, to the extremes. So it's dragged to the right. And the median is in the middle. Number 10, Obviously, this distribution has 2 peaks, so that is a bimodal, and symmetric, because you can see the symmetric, right? And number 1, those are about variance and relative standing. Which of the following is not a measure of variation? A. 5-number summary. 5-number summary measures relative standing. B. Range. C. Oh, okay. Not a measure of variation. It measures the relative standing, but also measures the variation. It's like let's say the box plot. If you have longer whiskers, that means the variation is bigger. Yeah, mean measures the center, so we should choose C here, okay? Yeah, range and standard deviation, of course, measure variation. 5-number summary technically measures relative standing, but it also gives you an idea about the variation. How do the values deviate away from the center, right? If the center is median here, Q2, if you have a longer whisker, it has a bigger variation. If you have a shorter whisker, smaller box, that means you have a smaller variation. Number 2, in a typical set of numerical data, would a fraction of the data value lie at or above the upper quartile? Upper quartile means Q3. Lower quartile is Q1. It's just a different way to describe them. Upper quartile here is Q3, okay? Of course, you have a quarter values above Q3, 25%, so we choose B. Number 3, find the range of the following set of data. The data has 1, 2, 3, 4, 5, 6 values. Minimum is 62. Maximum is 98. You take the difference of them, you have the range. Range is 36. Range simply equals maximum minus minimum. Easy. Number 4, find the upper quartile, which is Q3 for the following data set. And we can see we are lucky that the data set is already sorted from the smallest to the biggest. And we can find the median. Median is right here, right? And for the upper half, top half values, the middle of the top half would be the Q3. Yeah, we have 1, 2, 3, 4, 5, 6, 7 values. We remove the 3 smaller, we remove the 3 bigger, and 84 is in the middle. That is Q3. Excuse me, that is Q3, okay? Number 5, a set of data consists of the numbers. Find the 5-number summary for the data. Just know 5-number summary includes minimum, maximum. I believe you know how to find the minimum and maximum, right? Also contains Q1, Q2, Q3. Q1 is the median of the data set. Q2. Q2 is the median. Q2 is the median of the data set. Q1 is the median of the lower half. Q3 is the median of the top half. So I'm going to leave this for you to figure out. Number 6, you are looking at a box plot. It's just that this box plot is goes vertically. You need to approximate. You need to find how many of these students are between 43.5 and 46.5, between Q1 and Q2 and Q3, right? You know 25%, a quarter values. You know a quarter values is between Q2 and Q3. And in total, you have 160 students. A quarter of 160 is 40. So you have 40 students fall between Q2 and Q3. Number 7, you have a data set, find the standard deviation. Did I show you how do you find the standard deviation earlier? Use the calculator, okay? We don't do manually. Number 8, we need to find the range. Range rule of thumb. Let me explain what is the range rule of thumb, right? Number 8, range rule of thumb. Range rule of thumb gives us a fact about the distribution of any given data set. All right? Let's say we have a real number line here, and this is the mean, that's the center. This is the center mean x bar plus twice of the standard deviation. And this is the x bar minus twice of standard deviation. Okay, so if you have a value in the sample fall above bigger than x bar plus 2s, we say that value is unusually high. We have a standard for that, or significantly high, statistically significantly high, or we say unusually high. If we have a value less than x bar minus 2s, we say that value is unusually low. So that's the criteria standard in statistics. If the values fall between x bar minus 2s and x bar plus 2s, we say those values are usual. Okay, that is the content of range rule of thumb. So if we assume all the values are usual, we don't have outliers, very, very big. We don't have very, very like unusually low values. Assume all the values fall between x bar minus 2s, x bar plus 2s. Then the range, maximum minus minimum, would be 4 times standard deviation, right? Because you have 1, 2, 3, 4. Because you have 2, this is a 1s, 2s, 1s, 2s, together you have 4s. So you can use the 4s to approximate the range. Suppose you assume all the values are usual, right? If you assume all the values are usual, then you could use 4s to approximate the range. And the other way around, you could use range over 4 to approximate s, the standard deviation. So range rule of thumb gives us a way to approximate or estimate the standard deviation. Okay, so in this case, you can find the maximum, which is 18.6, minimum 17.2, and the range is maximum minus minimum. And if you divide the range by 4, you get a 0.35. 0.35 by the range rule of thumb could be a good approximation of the standard deviation. If you use your calculator, you would find out the actual value of the standard deviation is 0.346. So you can see the approximation is pretty close, right? The approximation is pretty close. That is an application of a range rule of thumb. All right, so we basically covered everything. Measure of mean, measure of center, that's the first thing. Measure of variation, that's the second thing. And a measure of relative standing, that's the third thing. Yeah, repeat videos and email me if you have any questions. Okay, thank you for watching.